Alright, here we are back again with the Compass 3D Plus build video. I've basically, this should be, as far as I can tell, pretty much the final section or the final piece of the puzzle for the final build and head setup and electronics installation, etc., etc. Starting out, basically what I've done is I've turned this front radio tray, I've inverted it, I've turned it upside down, and the reason for that is I wanted to mount my gyro up front, and there's no flat gyro mounting surface up here, especially with the original radio tray mounted the right side up. It's on a slope. That's no good. We want it perpendicular to the main shaft, so I mounted it upside down, and that makes the top of it perfectly flat and perfectly perpendicular to the main shaft, which is what we want. So I've mounted the gyro to the top of the radio tray there, as you can see. It's the Align gyro, the GP750 gyro, and I've simply put some Velcro around those. Now that the radio tray, because it's nice and solid, you can drill any number of holes, small holes, as you can probably see there. I've drilled some small holes in there so that I can fit some zip ties around the outside of bits that I've already Velcroed. I never ever put zip ties directly against wiring because it can rub and abrade on a nitro helicopter due to the vibrations. But what I've done is I've put little strips of Velcro around the pieces to protect them from rubbing on anything, and then where places where they needed to be anchored to the radio tray, I've actually drilled holes in the radio tray and put zip ties around the outside of the radio tray and then around the outside of the Velcro so that it doesn't rub. All areas where wires are exposed, I've tried to protect them as much as possible from rubbing. The way that I've done my layout is very simple. With the Align 2-in-1 power switch and igniter is there on the side frame. The receiver is there in that side of the radio tray. Governor and satellite receiver is on top of the radio tray there. Turn the heli around, you'll be able to see this side here. You'll be able to see the Align battery that comes with the 2-in-1 regulator. I'll swap that out at a later date for a higher capacity, better quality LiPo pack, but that's just what it came with, so that's what I've left on there for now. I've left the plugs on the end of the wires the same. I'll upgrade those wires and go to Dean's plugs at some stage as well, but I've just gotten it going for now. I've put the 2-in-1 regulator, I've mounted that to the bottom of the radio tray with some double-sided tape, and yeah, it all fits together nicely. There's plenty of room on this bird for electronics. There's going to be plenty of room for a governor. There's several different places I can mount the governor, whether it be there on the other side, on the frame set. There's various different places to mount things. Unlike the old Knight 3D, the old Knight 3D was a bit limited on radio electronic space, so they've done a good job on increasing the amount of space with this nice, almost T-Rex 600 style net, should I say, radio tray that the T-Rex sort of pioneered, and many other manufacturers have gone to that similar style radio tray, and it works really well. The other thing is I've obviously mounted all the servos, and I'll just explain to you how I did the head setup as briefly and concisely as possible. Essentially, this bird is set up very similarly to the way you would set up any ECCPM based helicopter. It's got basically the control rods from the servos go direct to a series of bell cranks, which then actuate directly on the swash. It's these three links here at the 120-degree points on the swash plate that these links here determine the swash height in terms of its overall travel on the main shaft. And if you follow the length in the manual for these three links, it will generally put you very, very close to the very center of the capable travel of the swash plate on the main shaft. So I followed those numbers. Compass recommends that your servo horns, the actual links versus the center of the servo horn, be 11 millimeters. So 11 millimeters from the center of the servo horn to the actual link. Now, these Align servo horns do not have one that is 11, so it's about 13 mil is where the nearest hole was, and so I'd rather go up than go down in terms of overall throws. So I've moved up to 13 mil. So far, it's worked absolutely fine in terms of my swash mixing in my radio. No strange swash mixing values. I may have to wind back my swash mixing values a little bit because I do have increased throw versus an 11 millimeter distance, because I've got about 13.5 mil. It increases the overall throw, loses a little bit of resolution, but for me it hasn't posed any problems. So that's what I've run with, and if I run into any problems, then I'll make adjustments at that time. I can get wheels that I can drill, etc. So basically what I did is I plugged everything in. Before I tidied up the receiver, I plugged all the servos into the receiver in their appropriate ports, and I'm using a 9-channel JR receiver with my JR DSX9 radio. So you need to go into your radio and you need to go into 120 degree in your swash menu for swash choice. It needs to be 120 degrees CCPM. So go in there, go through all those settings, make sure that the mode in your radio is set up correctly for the way that you fly. Basically start with a fresh new model so that there's no settings in there that can screw anything up. Go through and set all the default settings and switches and make sure that you deactivate variable pitch trim if you've got it, variable throttle trim, turn those all off, so that way you don't get any strange setups if you move any levers or buttons on your radio during setup. You don't want anything strange to happen. Now what I do when I first start to set up the head is I go into my pitch curve and I make it a straight line 50% all the way across, and then that guarantees, regardless of where my stick is, my pitch stick, that I'm exactly at mid stick in the radio by making it 50% all the way across for the initial setup of leveling the swash and putting it at the center of travel. That's what I do. So I put it at 50, 50, 50 all the way across. I make sure that my servo horns are 90 degrees to this line of rotation, and I'll just going to grab a ruler and show you how it is easy to do that to make sure that you're exactly at 90 degrees. Basically what you do is you want to draw a line between the point of rotation of the bell crank and the center of the servo, so that line and that line there. Now you just need to make sure that at mid-stick, or 50% on your pitch curve, that this end, so the servo horn, and this end back here form a 90-degree box with the arms. So essentially what we want to do is we want to make this servo horn, when we line up those two pivot points, we want to make sure that this servo horn is exactly 90 degrees to that straight line, and we want to make sure that this back one is perfectly 90 degrees to the straight line. Now Compass have done something really, really smart in terms of making sure that you get this bell crank here lined up and even with the opposing bell crank on the other side. There's actually a marker in the frame, there's a hole in the frame that the front of this T lever lines up with. It absolutely lines up with when it's set up. The geometry is correct on both sides. Both T levers line up exactly. The front of that draws a straight line between that pivot point, so that pivot point there, the front of the lever, and that hole in the frame, which you can see, they all line up and make a perfectly straight line. And that helps you to get your swash very, very close to level out of the box, even if you don't have a swash leveling tool. So essentially, anything that rotates like this, any of your servos that rotate, you draw a straight line between the two opposing pivot points. You make sure that each end is 90 degrees to that pivot point. Then you've got a perfectly square 90-degree control system. Do the same with the other side. Both with this servo here and that bell crank there. Make sure that that's at mid-stick or 50% on your pitch curve. Make sure that those are 90 degrees to that straight line, the servo horn and the bell crank at the end. And then obviously with the elevator servo, do the same thing. That point there and that point there on the bell crank, make sure that at mid-stick, 50%, that you are 90 degrees at either end to that with that bell crank. And essentially when you are, this lever, this silver lever that attaches to the bell crank for the elevator will be straight out, and you can view it straight through there. Once you've got those to 90 degrees using your servo horns, rotate them spline by spline until you get them to 90 degrees. If you have to use a couple of points of sub-trim, that does not pose a problem, but try to keep it to about 5 points of sub-trim or less so that you don't get into problems when you start doing your overall travel adjustments.